All right. So yesterday we introduced not only volume, but we introduced volumes of prisms and cylinders. So tell me, what are some of the things you remembered from yesterday that prisms and cylinders have in common? What are some of the things that you remember that prisms and cylinders have in common from one day ago?
Is it the rectangle?
Well, if you're saying that they both have rectangles going around them laterally, then yes, that's one thing, but that's probably not the main thing that they have in common. What do prisms and cylinders have in common? Which is what we did yesterday. What do those have in common? Like, we spent an entire lesson on this. You went home and watched the video again to make sure you remembered everything.
I don't know. I'm confused.
We had a lesson yesterday on prisms and cylinders, and I started it off saying, hey, look, let's compare and contrast. And I was like, hey, guys, you know what both of these have in common? They all have two bases. So, like, you name a prism by its base. So, like, if I have a pentagonal prism, I have two pentagons. They have two bases, okay? A cylinder doesn't have an adjective describing it, but just it's inherent that when you call something a cylinder, the base is a circle, but the point is it has two bases, it has two circles, okay? When you have a triangular prism, there's two bases, there's two triangles. Then you go into what Esme said, well then yes, in addition to that, they have rectangles going around, okay? So now we can get that logic and transfer it to two new solids today, which are pyramids and cones. But since this is kind of looking like it's going to be a rough day today, I guess I'm going to have to just do more talking than asking. What do these have in common? Well, these have one base. Now, pyramids, just like prisms, you name them by the base, but now there's only one base. So like a triangular pyramid, a triangular pyramid would have just one triangle. A trapezoidal pyramid would just have one trapezoid as a base. A hexagonal pyramid would just have one hexagon as the base. So here, these only have one base. What does a cone have as its one base? What is the base of a cone? Oh dear. What is the base of a cone?
Circle.
Yeah, circle. Okay. All right. Another thing they have in common, whereas prisms have rectangles going around laterally, pyramids have triangles going around laterally. Look, triangle, triangle, triangle. If you go around the sides laterally, they have triangles going all the way around. Okay. Now, a cone doesn't have like multiple triangles going around, but if you were to get to go and get a like one of those little paper cups that you pour water into at a water cooler and like cut it and unwrap it, it wouldn't be exactly a triangle, but it would kind of look like a triangle. Okay, so that has like a triangle being wrapped around. Now, when it comes to the formula for volume, yesterday you saw this capital B, which Irma knew meant area of base. You still multiply times the height, and the height is still found the same way. But now since there's only one base, it's going to be from this tip called the vertex straight down at 90 degrees. That's the height. But then the new thing for pyramids and cones is that you have to divide by 3. Now some books will just give you this general formula, and you have to go discover, based on what the base is, what each specific formula is. But Papa Romero is going to take care of you, and I'm going to give you the formulas to some of the common pyramids and then the cones. Let me get this stuff out of here. Okay. The most common types of pyramids, really I'd say the most common type, meaning like what you're most likely to find in a standardized test, is a square pyramid, but I could even extend that to a rectangular pyramid. Notice that what both of these have, they both have where you're dividing by 3. Now I don't have a legend here really where I describe what each of these mean. This is an S here, not a 5. What do you think that S stands for on a square pyramid? What do you think that S stands for on a square pyramid? Please don't say the square. What are some of the things we know about a square?
Does it mean sides?
It does mean side. Since a square has all the same sides, what this is telling you is to just get one side of the square and square it. So it's one side squared times the height of the pyramid divided by 3. A rectangular pyramid would be the length and width of the rectangle times the height of the pyramid and then divided by 3. The trapezoid and the triangle, the thing is the area of the base already has division in it, so I just kind of watered it down and made it easier for you. But just be aware that for these two, you're dividing by 6, not by 3. I just got the formula and I simplified it for you. And then the cone, our favorite. Irma, where does pi r squared come from? Yeah, the area of a circle. And since we know that a cone has a base that's a circle, it's pi r squared times the height of the cone and then divided by 3. Cone and square pyramids are going to be the most common. So then all I wanted to do was just do the first 2 examples from here. Square pyramid, very common. Let's find the volume. What was the first thing I needed to know for the volume of a square pyramid? What's the first thing I needed to put into the formula? Volume of a square pyramid. What do I need? So you can finish on time. Just go back and look at the notes that I already, because nobody prints out the notes. I have to hold this up here. Okay. Yeah, thank you. Thank you. A side squared. Pick one side of the square and square it. So I know a side is 11, so it'll be 11 squared times the height of the pyramid. Now see, look, be careful, because now these diagrams, it's not that it's misleading, it's easy to read, but it's also easy for you to overlook things, okay? If you see a segment going from the tip and running down the face, that's called a slant height. The actual height of the pyramid is still from the tip, but now it's going straight down at 90 degrees. Now, luckily for this first example, that's what they're giving you. So I do have the height, which is 21. But then don't forget, it's easy to forget, you got to divide by 3. If it's a trapezoid or a triangle at the base, you divide by 6. For a rectangle or a square, you divide by 3. So this gives me 121 times an extra 21 divided by 3, which is the same thing as saying 121 times 7. Mohammed, you can confirm for me. We get 847. What's the unit? What would the unit be? ¿Cuál sería la unidad? What would the unit be?
Centimeters.
Close. Good. Centimeters cubed. All right, now this next one's a little bit weird because they should have drawn the diagram. Like I don't mind problems where there's no diagram, but this is not one to do it. And depending on what the diagram looks like, there could be more than one answer. So I'm gonna draw the diagram for you and then just copy it. Like it even took me a while to figure this out because they weren't descriptive enough. But just draw a rectangle like this. Then you just draw kind of a tip up here. And then connect that dot with all the corners of the rectangle. Okay. So the thing is, we have a width of 18. We have a length that's 11. but they're giving you a slant height, which is usually shown something like this, of, oh man, tell me I did this wrong. Cut it in half. Yes, I did. Let's do it the other way. Let's come down this face. Sorry. Let's go down this side, like that. All right, so they're giving you the slant height, which is 25. Well, I know the formula for a rectangular pyramid just says I need length times width times height divided by 3. The length and the width of the triangle I have. That's going to be the 11 and the 18. But I'm missing the height. I need the height of it. And they're not giving me the height, they're giving me the slant height. But if I get that slant height and I combine it with the height that I need, this is what I need, and a little segment like that, what do those 3 segments make together?
Right.
They make a right triangle, and I'll draw this triangle over here for you to make it easy, the same thing. So here's a right triangle. This was the 25. This was the height. In order to be able to find that height and use Pythagorean theorem, I need to know that distance. Assuming that this is not oblique, which they don't say it's oblique, this should be half of the side that it runs parallel to. So this is running parallel to this 18. How long should that side be? How long should it be if it's half the distance of that 18?
9.
Thank you. So now let's put this in Pythagorean theorem. H squared plus 9 squared is equal to 25 squared. H squared plus 81 is equal to 625. Minus 81 and minus 81 gives me 625 minus 81, 544. Now really what you should be, so this is not a perfect square. When I take the square root of 544, it gives me a decimal. But I don't have enough time today to go over how to simplify it. You should have done it in Algebra 1. You will do it again in Algebra 2. But we'll just cross that bridge another day. For now, let's just leave it as square root of 544. A lot of you have calculators that even do it for you. So the point is that square root of 544 goes here. So, but anyway, since that gives us a decimal, then let's just assume that they wanted us to keep that decimal. So let's put in the calculator 11 times 18 times square root of 544 equals, and then divided by 3. So we get 1539.4. Be prepared to have Pythagorean theorem problems. That's very common here. You should have all learned that in the first semester. What would the unit be there? What would be the unit for that volume?
Cubic meters.
Good, meters cubed. Okay. I'll continue tomorrow. Hopefully we can finish this packet. And then that way you can use the last couple of days to work on Khan Academy if you haven't started already. Hopefully you have started already. Any questions? Okie dokie. See you tomorrow.